This is a 10-inch Harbor Freight wheel that uses this hub that is squeezing the tire using those 4 bolts to apply that squeeze pressure. But that hub right there is in the way because this is the side that has to be mounted to the motor. This is going to be directly mounted to the motor to a plate that has 4 holes already matching the bolt holes of this style of wheel. So this all has to be removed. That way I can mount it on the motor and still be out of the way of the valve stem. This is the plate I'll be mounting the wheel to. It has to be welded to the motor mount that's behind there. Those 3 bolts hold it on temporarily. Having too much fun welding. Time to clean it up just a little bit so the bolts will fit. So the motor is mounted. I can take this off actually right now. And the spacers are tacked into place right through the paint, so that has to be cleaned up if I'm going to weld those on. I may end up cutting them off. So right now it's just mounted with 2 bolts. There needs to be a support piece that comes up through here and grabs onto this as well. That has to be attached as well. I'll be using this material right here. So I can take it from over here, mount it on that, and make a spacer that will hold that. And I would like to actually have a spacer down here to enforce this. We'll see if that's necessary. If it is, I can add it later. It's not a big deal. And now measurements of the wheel have to be made to match the mounting over here with whether the wheel is going to go. It has to be at the same height. And that's going to be a little bit on the tricky side, but I think I can handle that. My support bolts are 3/8 of an inch and my spacers are metric. So I just need to drill out the spacers to match. It's nice to have a lathe to do it. Okay, the motor is mounted. I need to mount the battery still and the controller and get that straightened away, so that's not quite ready yet. And the freewheel just barely made it on the frame, so a couple of plates had to be welded on to make sure that it was well supported. And it's about equal in ground clearance. It's not bad. Here are the batteries that are going to be used initially. 2 12-volt batteries making the 24-volt system through this control box that I 3D printed. And why did I 3D print it? Because I can. These are the accelerator support plates that I welded on. So there's a box that I made for the batteries. I'm not going to show you the box being made. Everybody makes a box. The control is a 48-volt control that's already wired into its own box. And it's the issue is this little switch had to be added on to the accelerator because the accelerator is a Hall effect accelerator. It allows the 15% of the voltage to get to the motor at all times unless the switch is cutting it off, and even at full acceleration only allows 85% of the voltage to get the motor. So to solve this problem, this micro switch was added to the side of the accelerator, and this pad was added to the accelerator to push against or be the actuator against that switch. The problem being is that actuator is very short and it was not flexible. It did not allow for minute control of the speed. It was it's a little too stiff in its flexibility and had to be changed. So the new iteration allows for a lot more flexibility and
gives the kids a lot more control for their speed. Well, there you have it. There's the drive line, the motor, the control box with the key so I can turn it off, the batteries and the initial. That's actually 36 volt setup right there. And of course the control box that will go up to 48 volts.